So what we're going to work on today are our inequality word problems. So we've done our regular equations and we did word problems with our regular equations. Last class we solved our inequalities, so now we're going to do some word problems that involve our inequalities. So some phrases that you are going to see, if you see is more than, exceeds, or is greater than, when you write your inequality, that's purely going to be the greater than symbol. So if I were to graph that on the number line, that would be an open circle on my 1, and my shading would go in which direction? To the right. So again, that's when we see the words is more than, because we've seen the phrase more than before, and we knew that meant to be adding. As soon as they throw that word is in there, that means it's our greater than sign. Exceeds or is greater than. There's only one way for the other symbol, is less than. It's pretty self-explanatory. Again, that word is how you know it's the less than symbol versus the subtraction problem like we did before. So open circle on the 3, shading would go to the left for less than. It would not follow the sign if I wrote it this way. So you can't go with the if follows the sign. It does not always work. Does not always work. Okay, for our next one, is greater than or equal to, is at least, has a minimum value, or is no less than. Those phrases tells you it's greater than or equal to. The one that gets most people is the at least. You see that phrase at least and you think to yourself, well, least sounds like less, so that needs to be a less than sign, but it's not true. The example I always give is you need to be at least 16 years old to drive a car. So that means you need to be 16 or older. So you always got to try to put it in terms of things that you know. So when we have the or equal to, that means we get a closed circle. Greater than tells us to shade to the right. Really? No, just to go. I know that's exhausting, especially when it's touch screen. It's very difficult to do. All right, so here's our words for less than or equal to. So is less than or equal to. That one's pretty easy. Is at most, has a maximum value, or is no more than. They're not trying to mess you up. So again, the or equal to means it's a closed circle, and it would be shaded to the left. So let's try some examples. So we have the student council votes to buy food for a local food bank. A case of 12 jars of spaghetti sauce costs $13.75. What is the greatest number of cases of sauce the student council can buy if they use at most $216 for this project? All right, first question. What are we looking for? Number of cases. So I'm going to say, let's C equal number of cases. Now the fact that there's 12 jars in a case, did we even need to know that? No, that's extra information. We can just cross that out. So how much does each case cost? So $13.75C. They can use at most 216. So if we look in our list above, at most is which sign? Less than or equal to. So it's going to be less than or equal to $216. So then we'll divide by 13.75. And we will get a decimal, so we want to write the whole decimal out. Generally, bugs crawl. Yes. 216 divided by 13.75. What'd you get, Jordan? Well, give me the whole decimal.
The whole decimal?
Yeah. 15 point what? 7. Okay, there's a 7 there. 0.7. And then is it 090909? Yeah, the calculator rounds it because it can't keep going on forever. Okay, so 15.70909. Can we buy 0.709 of a case? No. No, it's either the whole case or it's no. It's a less than. B is less than this, so we've got to go down. They can buy 15 cases. If they were to buy 16, they would be too high. They would have gone over their $216. All right, our second one, the larger of two integers is 6 times the smaller. The sum of the two integers is less than 49. Find the largest possible values for the integers. Okay, how many integers do we have again? 2. So we have 2 let statements. We always have one of them that's just an x, and it says the larger of two integers is 6 times the smaller. Smaller is mentioned last. There's your x. So let x equal smaller number. So then the larger one is 6 times the smaller. So what is our larger integer? Matt? 6x.
Oh, I wrote x times 6.
Well, x times 6, 6x. Same thing, but we usually put the number in front. All right, so then it tells us the sum of the two integers. The sum tells us to do what? Add them. So x plus 6x is less than, that's my less than sign, 49. They generally don't like you to do that right away. You usually want to see the equation/formula first. So when you add them, you do get 7x, so we divide by 7. X is less than 7. So what's the largest possible number that x could be? 6. It says x is less than 7. It's not equal to 7. I can't use 7. So the largest number that x could be is 6. So if x is 6, what's my 6x going to be? 6 times 6, 36. So we just have to write a sentence. The largest possible numbers are 6 and 36. All right, number 3. The sum of 3 consecutive integers is at least 20. What are the smallest possible integers? So we got 3 of them. So we need 3 let statements. They just told us they're consecutive integers. So what's our first one going to be? So let x equal first integer. Yep, they're consecutive, so the next one would be x plus 1. And what's our third integer? X plus 2. Remember, consecutives go up by 1. Consecutive evens or odds go up by 2. So again, it tells us the sum of them. That means I need to add x plus x plus 1 plus x plus 2. It says is at least 20. So what's my inequality going to be for this? Yeah? Greater than or equal to. Because if it's at least 20, that means I could be more than 20 and be very happy with the situation. So combining our like terms, I get 3x plus 3 is greater than or equal to 20. So subtract 3. Divide by 3, we're going to get a decimal. What's up, man? Oh, thank you. I think your calculator then rounds it to a 7. So again, it has to be integers. So can I use 5.6? No, that's not an integer. You cannot have decimals for integers. So we're greater than this time. So what is the integer that's just higher than 5.6? 6. So x would be 6. What would my x plus 1 be then? And x plus 2, 8. So the smallest possible integers are 6, 7, and 8. And again, we went with 6 because that's the smallest one. They wanted the smallest possible integers. You got a lot of numbers, a lot of integers that are greater than 5.6. We wanted the smallest one though. In the figure below, we have rectangle ABCD has a perimeter that is at most 44 feet. Write an inequality that models the condition and then solve the inequality. So perimeter means we do what with our sides? Add them all together. But keep in mind, we've got 4 sides to the rectangle. Usually if the rectangle is labeled like this, where only 2 of them are labeled, a lot of kids forget to add up all 4 sides. So you got to remember, there's 4 sides to this rectangle. So you have 2 times your length, so 2 times my x plus 7, plus 2 times my width, my 4x minus 5. They told us it is at most 44 feet. So which inequality do we use for at most? Less than or equal to? There we go. I'll give you guys about a minute, maybe a minute and a half to solve that. Do we get x is less than or equal to 4? Yep. Now, did it tell us we had to actually figure out what the length and the width of the rectangle were? No. They just told us to solve the inequality. So we're done with that one. We don't have to do anything else with that. Now, if you did go ahead and figure out what those were, you certainly will not lose points. But you didn't have to for that one. Okay. Lisa brought half of her savings to the bakery and bought 12 croissants for $14.20. The amount of money she brings home with her is more than $2. Use an inequality to find out how much money she had in her savings account before going to the bakery. All right, so what should our x be? Amount of money in savings. That's what we were told to find, we said. Find how much money she had in her savings account. Now, when she went to the bakery, though, how much of it did she bring with her? Half. So we're going to start with 1/2 x. Because x was all of her money in her savings. She only brought half of it, though. And then she bought her 12 croissants for $14.20. So we want to subtract that, minus $14.20. The amount of money she... What's up? It didn't matter how many she bought for the $14.20, just that she spent that much. The amount of money she brings home with her is more than $2. So this one would be a greater than 2. Is it going to be equal to 2? No. They said she brought home more than $2, not $2. There we go. There's our inequality. We need to solve it now. We add our 1420 over, so we get 1/2 x is greater than 1620. Remember, multiply times the reciprocal, so times 2. So when we multiply, we get x is greater than 3240. So how can we answer the question? It says, use the inequality to find out how much money she had in her savings before going to the bakery. How could we answer this? Jessica? We could say it that way. Yep, that's one way. We could say she has, well, not exactly 3240, because it's got to be greater than. We can say she has more than 3240 in her savings, or she had it because she spent some. So she had more than 3240 in her savings. So by using that phrase more than, that means we're not including the 3240, we're saying it's higher than that amount. She had more than 3240.